Okay, here is another extra example of doing limits sort of from first principles of understanding limits, what they mean. So not trying to calculate limits using the rules for limits, but really understanding what the limits are. And in the previous examples, we did a lot of examples with pictures, graphs, understanding what it looks like visually. In this example, it's with algebra. And we have this piecewise function. It's the function which is 0 if x equals 2, and it's x if x is not equal to 2. So now let's do these limits. And we're going to start with the limit. Let's do this one first, part A. The limit as x going to 2 plus of f of x. And what is that equal to? And the important thing to realize here is that when x is going to 2 plus, that means x is getting really close to 2, but x is bigger than 2. So x is bigger than 2 by a bit. So it means 2.1, 2.01, 2.001. It's getting really close to 2, but always a little bit bigger than 2, never equal to 2. And in this situation, because this is bigger than 2 and not equal to 2, we are on strictly this branch of the function. We never see this thing, the 0 if x equals 2, we never see that because x is never equal to 2. It's always a bit bigger than 2. So it's a bit bigger than 2. We're always on that highlighted in yellow x not equal to branch of the function. And so every time we see an f of x, we can replace f of x with what it is over here. And here, in this case, it is x equals x, right? This x. F of x equals x. We're always there. The 0 is totally irrelevant to us. We might as well be dealing with just x. So x is getting really close to 2, and the y values are y equals x, right? We're saying y equals x here. What are the y values getting close to when y equals x? Okay, if x is getting really close to 2, it's always a bit bigger than 2, but it's getting close to 2, then what is x doing? It's getting close to 2. So this limit is equal to 2, equals 2. So as the x values get close to 2, y equals x, that gets close to 2 as well. So that's 2. Great. Part B, same idea. And in fact, it's going to be a very similar argument here. This is the limit as x goes to 2 minus, and that means x is slightly less than 2. But for this particular function, it doesn't matter if you're bigger than 2 or less than 2. As long as you're not equal to 2, you're on this branch. And so we're still on this branch again. X is not equal to 2 here. We're still on the same branch of the function. Same exact argument as before. We can replace the function with x. So for other examples, maybe it matters if you're bigger or less than 2. There was an example in the notes like this that we did in class. It was this one, whereas bigger than 1 or less than 1 were different. But in this one, as long as you're not equal to 2, it's the same thing. It's x. And if x is getting really close to 2 from the left side, then what are the y values doing? They're getting close to 2. So both limits are 2. So if both limits are 2, the left limit is 2, the right limit is 2 by the result for two-sided limits. Therefore, the limit as x goes to 2 of f of x is also 2. As soon as they are equal to each other, in this case they're both equal to 2, then the two-sided limit exists and is equal to 2. And there you go. That's it. It's 2. This shows you, what is the whole point of this? This shows you that this whole shebang, 0 at x equals 2, it never mattered. That never came up. What happens exactly at x equals 2 did not matter for any of these limits. So if you did option D and you said what is f of 2, the answer is 0 because you're on this branch of the function. And this f of 2 equals 0 has no effect at all on any of these 2, 2, 2 limits. So the limit is 2, even though the function is not equal to 2. The value of the function has nothing to do with the limit. And in fact, this example is an algebra example of a picture we did in class. So we did this one in class. It looks like this. So here's the function. It's the function which is y equals x. But then exactly at 2, it has a hole where things got moved down to f of 2 equals 0. And the point is that the left limit and the right limit are both 2. The two-sided limit is 2. And the value of the function is some completely other number that has nothing to do with the limit. Okay, that's it for that example.